Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll work on partition equal subset sum. So the problem states that we are given an integer array nums and our task is to check if we can divide it into two subsets such that both subsets have the same sum. If that is possible, we will return true, otherwise we will return false. If you consider example 1, so we can split this array as 1 plus 5 plus 5, 11 and 11 alone. So since we can split this given input array into two partitions of equal sum, we will return true. So the key insight here is if the total sum is odd, then it is impossible to partition the given array into two parts with equal sum. So because two equal integers cannot add to an odd number. So the problem becomes, can we find a subset whose sum is total sum by 2? So we need to check if there is a subset with sum which is equals to the target. This is a classic example of 0-1 knapsack, pick or non-pick problems. So the idea for brute force approach is at each index we will pick the number or we will not pick the number. So we will stop when the target becomes 0 and that means it is success. If the target becomes negative, then that is invalid, and if the array ends, then it fails. So we will return false. So first let's calculate the total sum of the given array. Let's initialize a variable sum, and for each number in nums we will add it to sum. Now we have the total sum in sum. Now we will check if the sum is odd. If the sum mod 2 is not equals to 0, which means it is odd, and we will return false. Otherwise we will split the sum into two parts, so sum by 2, and this would be our target. So then we will return, we will call solve, we will pass the given nums 0 and target. 0 is nothing but the index here. Now let's implement the solve method, and the return type would be boolean. Solve, we are passing nums, index and target. Now we will see if this target is 0. If this target is 0, which is our base condition, we will return true. Or we will check if the index is equals to the last element, or if the target is less than 0, which is negative, then we will return false. That means it is invalid. Otherwise we have two options, either we pick the number or we will not pick it. In case if you pick the number, then we will call solve nums, we will increment the number to index plus 1, and target would be target minus current sum, because we have picked it and we need to update the target. In case if you did not pick it, boolean not pick, then we will call solve nums, we will update index, and we will pass target as it is because we did not pick it. Now we will return true if either of these is true. So we will simply say pick or not pick. Let's run the code. It is accepted. So the problem with this recursion solution is the time complexity will be 2 power n because we have two options, either we pick it or will not pick it at every step. So there are a lot of repeated sub problems. So we need to find a solution for this, maybe using a dynamic approach. Let me comment this first. And yeah, so yeah, the solution will almost be similar. Let me copy this and paste it. Okay, so here similarly we are taking a variable sum, we are calculating the total sum, and we are checking if it is odd, we will return false, and we will take the target as sum by 2. Now we need a DP array, maybe of type boolean, and it would be nums dot length, and this would be target plus 1. Okay, then we will return num0 target, and along with it we would return DP. Now we will implement this solve method. The solution is almost same, just that we are updating it in the DP array to avoid recalculations. So since we are passing a boolean DP, let me pass it here as well, and first we'll check if target is 0, we'll return true. If the index is equals to the last number or the target is less than 0, then it is invalid, we'll return false. Now before calculating, let's check if DP of index of target is not equals to null, then it is already calculated. So we will return DP of index of target. Otherwise, similarly we will call pick and non-pick, and we will pass nums index plus 1, target minus current element, and along with that we will pass DP2. DP and here DP. Alright, and before returning, we need to update it in DP of index of target. Then we will return this one. Let's run the code. It is accepted. I am submitting it. Okay, it is accepted. You can also try this using the bottom-up approach or tabulation method using the for loops, and then you can also optimize the given space by traversing from backwards. So yeah, the time complexity would be O of n into target, and the space would be O of target for recursion space. So yeah, that is it for today's problem, and I will see you in the next one.